Okay, so let's take this very seriously. I'm just giving as an intro, and I want everyone to kind of go look a bit more deeper into these. The question is, what are the tech essential every Scrum Master should know? Like, if you're working with a Scrum team, what are you expected to know in terms of technology, in terms of terminology? Now, this is going to be very important and help you to really, really communicate effectively whenever you find yourself in an interview. And I want this to be like a second nature when you talk about, oh, I work as a Scrum Master, I work with my team. Now, the difference I want us to see after we go through this training is when you're giving an example, I want you to say, oh, I remember when we were working on API to connect A and B. I want you to say, oh, I remember one of our containers were shut down and then we had to replace it. And because of that, every work has to stop. Now, this is the reason why we want you to kind of get a bit understand what actually goes on within a team. Now, this is also going to help you to understand or to figure out when we talk about a work with a team, you want to think about what type of team is it and what type of application are they actually using. And when you kind of consider this, you realize that Scrum in itself or the technology or being a software developer is not difficult. What is difficult is just that we have been able to kind of focus our mind only to understand the leadership aspect of it. Now, if we were to say that the technical aspect of this is engaged in the process also from the start, then it definitely will help us align more better. Now, one of the reasons why it's possible for us to reset our mind, because right now I want everyone to reset their mind, is because when you reset your mind, it becomes more easier. Now, do you know that if you want to live in Germany, the first prerequisite is that you need to speak German? Like if you want to live and work, even if you're not working in English, the first prerequisite is that you need to speak German. And I'm amazed how many people can learn German in less than 90 days and speak German fluently just because they want to go work in Germany. All right. So it simply means that we can all learn every stuff. Now, why technology matter? Why is it important for us to understand technology? To communicate effectively. All right. To communicate effectively. Let's say that your team is working on a deployment, and let's say they're moving stuff from their physical disks or they're moving stuff from on-prem into AWS cloud. Do you actually understand the technology that go on behind? If someone say, hey, look, I'm stuck. One of our cloud system is not working. I'm stuck. We are unable to validate the quality of data because we do not have the right security system installed. Can you have an understanding of what they're talking about? Can you make an informed decision to like, okay, I understand what it's about, reach out to this person. So to better support your team and drive continuous improvement, and also to be able to figure out how to help your team and also to align with business goal, we need to understand and master the core technology used by your Scrum team or used in software development. But then before we get into that, we also need to understand what building a software is all about. All right. So if you've been in interviews or recruiter call, they will ask you, oh, how many years do you have in SDLC? Right. How many years of experience do you have in SDLC? You know, recruiters can ask very funny and stupid questions some of the times. Right. And you're like, how many years have you done Scrum? It's like 10 years. How many years have you done Agile? And then, so why? Because they're going by the book. But you understand that everything about building a software, it doesn't matter if it's Scrum, it doesn't matter if it's waterfall, The process is what we call the software development lifecycle. It simply means that when you're about to build an application or launch a new product from start to end, what are the different processes that the product goes through? And then we understand that every product, it doesn't matter if you're in Agile or you're in Waterfall, it always starts with project kickoff and initiation. Now, if you're in Agile, you would do it from maybe a requirement gathering by looking at the product design, by looking at collecting a couple of requirements. But then if you are also in a waterfall, you will look at maybe looking at the SOW and looking at the planning phase with stakeholder, planning the execution, planning the monitoring and evaluation, planning everything, and then you start implementing. Right. So it doesn't matter if you're in Agile or it doesn't matter if you're in Waterfall, a software development cycle remains a software development cycle. So it's not a concept that is unique only to Waterfall. It's a concept that applies to all software that are being developed. So for you to build any software, we need to do requirement. We need to do what? Initiation. Now, initiation simply means that, let me bring this in the space of Agile. We cannot just start working on something when we don't think about where the money is going to come from, or we don't think about how is it going to benefit the company, how is it, all of this due diligence need to take place before we get into requirement gathering, right? Why am I making this point? Because most often requirement gathering is the most feasible state. Requirement gathering and planning is what we are all used to, right? And we don't look at, before we even do planning, there need to be a previous decision that necessitates us to be able to create or to embark on this project. Now, when we do our requirement gathering, we get into the analysis phase where we now start looking at uh, how do we build this? This might involve backlog refinement. This might engage more or less the PO communicating with the stakeholders, looking at should we do this? Should we not do this? If we work in a scale environment, this is going to be a perfect space from when we collect requirement from leadership or from the chief information officer or chief technology officer. The product team is going to sit back and go forward and back to see should we build this, should we not build it. It's at this phase where we decide or finally adopt what are the different features that need to be built, and then how do we now start breaking them into smaller features, which are called user stories and also tags, right? And then the design phase, it's also like, okay, we need to build these. How is it going to look like? Well, designing is very simple. It just look like we want to be able to build a new application on WhatsApp that enable people, let's say, to share photos among group of people, right? You can send one photo and you can decide to add many people in a container. Now we need to design how we want the effect to look like. It's like a picture. You picture how you want it to be like. Now the picture are also what help the development team to understand what to do. What is the process? Sometimes we call this the solution document, or we call it the flow diagram. How do we want the information to get across? This is very important. Now, when we actually do what has been designed or what we anticipate it to be, we do what? We do testing. It has to be tested. And when it's tested, it needs now to be deployed. Deploy simply means that we now send it to the environment where we can actually test it and see if it's performing what we anticipated in the beginning. And most often we do what? Maintenance, operation and maintenance. You realize if you use a phone, which I'm assuming everyone use, there is that constant probing, or there's that constant request for you to update a software, for you to update this. Why? Because there's constant maintenance and operation going into the market. And sometimes we have what is called end of life. End of life is a very big aspect in every software. Now, there are some software that are going to be rolled out with time because they can no longer support the technology. So they either replace them and because it has already maxed out the potential viable period. Now, what are the core technology which you should know? So number one word that every Scrum Master should understand when we talk about version control system. What's a version control system? Right. So it's more like, let's say, we're about to, if you're a bit familiar with Jira, for those who are familiar with Jira, we always have like, when you're tagging your release, you tag them in versions, version 1, version 2, version 3. Now, version control simply means that we are building something. When you start building, remember, in Agile, it's a whole lot of changes that is happening, right? There's feedback changes, feedback changes, feedback changes. But then there need to be that original form that is being built before you continue to make changes from the original, from the first phase of what you built. So version control, simply, it's more or less, it allows the developer to collaborate without overwriting each other work. So I can work on a part of the system, and then you can come and add on it without actually going back to rewrite or to redo everything. So it's possible for me to do a part of my work and lock it in a way that no one can come and change everything about that. So if you're coming to do something, you're coming to add. Now, if I want to change my version from version 1 to version 2, it should be because of feedback that necessitates the change, right? And that now become the new version control. So version control simply means I build the first version. You can come in, you can add security and other stuff. Now that's going to be what? Version 2. Why? Because most of the stuff have been added. Someone can come in and maybe add containers in there and other stuff. That will be what? Version 3. So version control now help the developer to collaborate in a way that they don't override each other work, right? So it's a very important thing for you to know. So there need to be a version control system. If not, you can edit something, someone can come and completely override it, and then you go back. What's what I was working for? Because the other person, maybe they were using a system that is faulty and it kind of clear off every stuff. So the version control system help us to maintain that, right? So you need to familiarize yourself with basic version control system. We talk about GitHub and GitLab as the two major control systems that help us to be maintain that that version so that different people can work on it at a time. Now, the second core technology you should know, I'm hoping you're writing this down so that you can go after and you can read a bit about it and look at how to integrate this in your project. CI/CDs too. You will see in almost every environment, what knowledge you have about CI/CD. Now, these are tools that help us to automate processes and also help us to integrate code changes, testing and deploying and all of that. Right. Then about what it does, and then master at least some of the tools. Jenkins, it and GitLab are some of the major ones that you should know on version on CI/CD tools. Now, the main purpose of CICDs, which I'm going to show you in the next slide, is to enable that loop, that communication in a way that we don't break the collaboration or we don't break the continuous flow. Why is it a very important concept in Agile? It's a very important concept in Agile, number one, because Agile builds incrementally. So you're telling me you will deliver the product to me in 50 different releases. How am I sure that after the second or the third release, you will not stop? Now, the concept of CI/CD come in to now demonstrate, okay, look, this is how we work. We ensure that the process of you getting the product, which is you getting in the market, and the concept of us planning to where we get it to you is the flow. So every time we plan, it's a continuous process. And then we allow the coding and then we build. When we test it, we're monitoring the entire, when we test it, we, no, this is wrong. It's not supposed to be released before deploying, right? So it's supposed to be the reverse. We deploy it, and then we can now do what? We can now release it. So this is supposed to be 6, and this is supposed to be 5, right? We deploy, and then we can release. Now, they could still be right. When you're releasing, you still need to do some form of deployment to the environment. But now, for understanding sake, after every time when we do our testing and all, we need to first of all deploy it in an environment, and then before we release it to our client. Now, when we release, we need to do some operation or maintenance within the client environment to understand that what we have given them actually works in their environment. And then we continuously monitor the effectiveness in the environment. Why? We have been building in our environment. When we send it to the environment, we don't know how secure the environment is, right? And that is why you realize now in most of the environment, there are levels of compliance that are needed from that environment for them to accept external software. And this is where the work of cybersecurity analysts come in, right? They need to analyze how secure is the system of our counterpart to be able to handle what we're giving them. So there are standards that help every company need to meet in such a way that I cannot send something to you, and because you're not taking good care of your environment, it go faulty and the fault is on me. So there are certain regulation and iOS rules and all of that that help to maintain that. Now, the concept of CI/CD, and you also hear about CI/CD pipeline. Right. It's simply what happened when we are committing to build something to where we release it. Right. What's the whole process that happened within this pipeline? Now you start seeing what happened. We commit to building, we trigger the build, we build it, we notify of build outcome, we run our testing system, what are the outcome, and then we deliver to the staging environment, and then we deploy. Now, the CI/CD, it's more like a feedback loop. Let's say, and it's automated. Let's say we trigger code testing to test to validate if what we have built is going to integrate with what we have built before. But if for some reason it's automated and it doesn't go through, it's going to kick back to say, oh, automation fail. Now, this now signal what? Signals developer or whosoever is working on it to say, look, there are a couple of, there's work that need to be done. So, because what you send in is not compatible. Right. So it's very important because it helps to facilitate and improve the entire process for all the team and help us to avoid errors. Right. But then if this was to do, if we were to do this manually, what happened? If I'm trying to integrate two code and they don't integrate, I can crack it, right? I can be able to do a couple of rewriting and then just make that work for some reason, right? So, but then automation will help us do this. And this is also the concept of DevOps, right? You know, when we talk about DevOps simply means that how do we enable the development team and operation team to collaborate? You realize that without the concept of continuous delivery, continuous integration, and continuous delivery, there will be no collaboration. But because we are ensuring that there is a flow in the entire process, we can be able to collaborate. Now, look at operation. What's happening? Operation simply means that when we finish building the everything and then we release it, what happened at the end? When we are sending it to our client environment, all the operation and monitoring most often is not longer on our dev team. There need to be a team that is in charge of that because that's already what? That's already consumable. So every operation or every rework that comes in is going to be in alignment with the contract that was drawn. And we understand that at the level of development team, we don't interact with contracting, right? So operation actually handle most of these. And if there's a case, there's a rework. And this is why you often been asked the question in your interview, how do you handle technical debt or how do you handle rework? Why? Because it's not work that is being kind of it bounced back at the level where the team is still working in. It is gone out of the environment. It has been validated as done, and now it need to come back into the company. So there need to be a whole process. If not, this is where we say, oh, a manager calls you at the middle of the spring to step in and do some work. What happened? Right. This was not planned, but this is an urgency because the customer actually like, you know what? You delivered this 1 month ago. We have it broken. Can you fix it? We're losing 500 clients. And also, business will not also want to lose their clients. So what are they going to do? Most often, they put the pressure on the team to step on it and do it. Now, this is where you come in as a Scrum Master to be able to protect the team, right? And by being able to create a container where all of these requests can come in, we can prioritize it, and then we can look at the influence or the weight it's having on our developer when these changes come. Now, being in company where we need to create a whole technical debt team because we were working with several clients and we're kind of installing sensor system in their different building. And you realize a sensor system can stop working if maybe it's used wrongly, right? Think about a sensor system is more like you opening the door of your fridge and closing constantly. Sometimes it might lose the alarm, right? So not because it wasn't done well. So all of this might come in like really, really in a high volume. So it will require now the system to readjust to handle this. So this is where they always ask the question, urgent work coming in the middle of the spring, what is it going to do? This is coming back because there is that constant collaboration between the dev team and the operation. And this is possible because of CI/CD. Now we go to cloud computing. Now, cloud computing is something you need to take a basic course in. You cannot ignore it. When we talk about in fact, we cannot talk about building an application or building an infrastructure this day without talking about some form of cloud computing. But cloud computing is not really that, I would not say it's not an out of the space word, right? When we talk about cloud computing, think about your phone. If you use an iPhone, they will ask you buy cloud space, which means that even if the space on your phone is 128 gigabyte, you can still store more than that space. That's cloud computing. Where is the information being stored? Right, you realize that sometime for you to retrieve that information, it's going to take some time to download because physically it is not in that phone. It is stored somewhere in the cloud. So cloud computing just enable us to collaborate, right? And you can also buy a cloud space and you can share it with other people and everyone can be able to interact there. An example is the Google Drive. The Google Drive, you can be able to share, add people there, right? And people can go in and just add information there. You can be able to share a Word document on a Google Drive and everyone can go in there and edit it. Collaboration, it is very, very important for us to understand cloud computing. It's a game changer as the IT market continues to grow rapidly. Now, when you look at cloud computing, you need to understand what are some of the most popular. There are more than these, right? But you don't need to master everything. So the one we recommend you master a bit of Amazon's web services because Amazon is definitely winning the market. Google Cloud Platform. We also have what? We have Microsoft Azure, and then IBM Cloud is also widely used in some cases. Now, we also have Salesforce. Salesforce also have its own cloud computing system, and then we also have Oracle. So those are some of the popular cloud computing system. You see Adobe Cloud also there. There's so many that you can note, but I would say that if you're building your project, at least think about a couple of them that you've been able to to work with. Yeah. So another one is Snowflake. Snowflake is gaining really quite a lot of popularity. So you might want to also think about snowflakes, snow and flakes, right? All right. So now when you think about cloud computing, also, you should also know that they're public, it might be hybrid and might be private, right? There are public servers where everyone can access them. There might be private, which is specifically to a particular server, and we can also use both public and private. It depends. Now, what makes the difference between public and private? Public simply means that we want to make the information more accessible to everybody. Right. If you go on your phone and you go to Google and you say something, what happened? It pulls information from a public cloud space. Right. If this information is in the private cloud space, you will never have it. So most companies on their data, they might use the private cloud space, especially data that it's highly secured and not people don't need to access them. Now we can use hybrid to limit what you can see. You realize that if you work in a company, depending on the position that you hold, there are certain information you can have access to, you cannot have access to. What happened? We can use a hybrid to like, okay, everybody that comes into this building, you can get into this space, but then we have also private spaces you cannot get into. And you look at cloud computing, we can have servers, we can have what? Storage, mobile devices, application, and database. All of them use cloud computing services. Now, the next thing, this one is also very important. Pay attention to this one. Containers. Virtual containers and visualization and containerization. And you want to pay attention to these two popular words, Docker and Kubernetes. Right. So when we talk about visualization and containerization technology, it simply enables developers to run multiple applications on a single physical server, right? Isolating them from each other to avoid conflict. So it's more like all of us are working in a space, right? Let's say we are all working in this space. We are all in one room working in a space. Now, let's assume that we are all sorting out some cookies, right? And everyone is being given different instruction on how to sort theirs out. So how do we ensure that everyone is doing the right thing and we're not having people mix up what they're sorting so we can come and give accountability? So we create containers, or containers simply means different holding. In most of the cases, you hear it, we call them portals, right? And most often the DevOps engineer will do that. So we create a portal or a container that is going to hold this kind of information. This container holds this kind of information. This container holds this kind of information. Right. When we look at API after that, we'll look at now how when you do a query, now the system can go into different container and pull out whatsoever they need to give you the result. Right. So Docker is a popular container tool that allows developers to package application and their dependencies into container. You see what I was talking about? We can pull them, package them, and then you can now say, okay, if I want to get, let's say, information from container 5, let's say I'm trying to pull out the financial report of my company, and it's in container 5. Now, container 1 have all the requirement I need to, let's container 1, to set for the password, right? So for me to access container 5, I need to put in my password that now trigger, let's say, code to be released from container 2. Are you seeing how this is dependent? From container 2, and then if this code is validated, I receive an SMS, which is in container, let's say 4, and then I can access container 5, right? Let's say container 5, I don't want the report. I just want to have a view of what is in the account, like a summary. Now, if I put my password and I get let's say, I get a confirmation by code, I can skip container 4 and I can go to container 5 just to see. I just want to see. I don't want to take anything out. Now, if I want to print out something, so this is now not you seeing the report, this is how you printing the report. When I trigger this and I go, it gives me access to container 4 and container 5. When I click print, it need to come back to container, let's say container 3 was here, and then check to see if the type of document that can be printed, because everything that has been written about the permission to print is put in container 3. Now we understand how container work, right? So when we say that we're building portals that give different commands. They are containers, right? It gives you access to this. There's one portal, there's another portal. So this is simply by writing code to say, okay, give access to this, don't give access to this. When someone enter A plus B, give them this. Those who have done a bit of automation, when you come to Jira automation, you understand what I'm saying. If A and B combine gives C, if this and this and this step is missing, turn it back to this. So that is how it works. Now you look at the virtual machines and then the container. So you see, application 1, everything is in one container, 2 containers. You see all of this. So you can see how we kind of section it into either a virtual machine or a container. Now, what is the difference between the virtual machine and a container? All right, those who work from home, you can know you can use your laptop and you access a virtual machine, which means that the information you're accessing is not going to be stored in your laptop. It's stored in a laptop somewhere you don't even know, but you can be able to access that virtual machine. Right. That is also the power of cloud computing, where we are able to be able to do what? Access a space on Amazon Web, access a space on Azure Cloud to be able to use it. Right. So every time you want to get it, you need to log in. But then if you're doing everything within your own space, every time you put in your password and so you can access it. Now look at your computer. If you log into your computer, you can see all your folder and every stuff. But let's assume that this was a virtual machine. Now it's not going to be in your physical computer. You just need a login and a password from any site to access to it. All right. So we also talk about APIs. What are APIs? These are tools that you're supposed to master. When we talk about APIs, what is it like? I love the fact that it says it's like a glue that connects different software, right? It's like a glue. When I do something, there is a signal that gives me a feedback. So they allow communication, application communication to each other, share data, and leverage external services. Right. And the application allow application to communicate with each other, share data, and leverage external services. Okay, this stuff. All right. So um, the representational state transfer and GraphQL are common API design patterns used in modern application. Right. So really bit about REST and really bit about GraphQL. Right. So those are two things you want to pay attention on. Don't just know API, but read a bit about these two systems, REST and GraphQL. And APIs are very simple. Every time we say, I work with backend developers. Backend developers are the one that kind of with the API. So you see, you sit in your computer at home, and then you are looking for a job. What happened? The system will need to tweak and like point you to JP Morgan side, point you to this. These are the back end, and then you communicate. But realize that for you to have access to these, what's going to happen? There need to be some form of connection. Yeah, if you're solving on the web, we need to be connected with what? With Wi-Fi, which more or less play the partnering between these. So there is always a middle person, right? The middle person that connects that stuff. In most of the cases, it's going to be like local network connecting you. And I love this example right here. You say, look, your API here is the waiter. You give a command, pap, you sit here and you're having your chat. And sometimes you're very upset why your food is not coming on time, right? Why there is somebody in the middle working heartlessly to make sure that you get stuff right here. So if your API fail, you hardly get any result, which means if your waiter go and they were not happy the way you spoke to them, they will not come back and you not have any food, right? So APIs are very important. When you can, a typical example you can give here, you can be like, let's say, working on, let's say, uploading a new application, a new seamless payment application, and then we have failure in the delivery of the API. That might kind of take your team about a week to locate what is causing this failure. Um, why is it that we cannot communicate with the server? Right. They will need to go do some troubleshooting, find out is it a security issue. And most often it's just going to be like a firewall blocking it, right? A firewall that is maybe now the system kind of identify that firewall as a virus. If firewalls are not given the right command, the system identify them as a virus. Now, if you install some application on your computer and you're working on some certain software, they will never function unless they ask you to delete these applications that are blocking it, right? Sometimes even when you're browsing on the internet, they'll ask you, "Oh, this is blocking access to this." So it need to allow you to now give a command for it to pass that approach. Now, these are like API. They communicate and make sure that we are safe before every information is given out. So we also have like outer APIs and inner APIs, like data source, and then inner APIs like the management system, right? When you pick in data from here, let's say um, we are requesting information about the number of people who attended mastermind today, right? We have the data source, which is the inner data. If let's say that a web developer is requesting it, the web developer may request it as a raw data, which is just going to be points and numbers and all types of code that are in there. They can know what to do with that information. But then if a layman is requesting it, there need to be some form of transformation in a way that it can read from here. So based on how this information is requested from the upper end, is going to determine, do we need to transform this information to put in here, or do we need to give it in a raw phase? Now, think about ChatGPT as a clear example. You give it some command to ChatGPT. Hey, ChatGPT, I need XYZ. Present it as a picture. What happened? ChatGPT will go into the data, pick out the data, and then do what? Convert it into a picture and present it to you, right? So you might have like the API maintenance. You may have like outer APIs and inner APIs, which help us to do exactly. Now you also have security. When data come in from here, how do we ensure that the data you're seeing is secured? Right. You might set, for instance, you might set the iPad or the tablet of your kid to like, if any information is coming in, which is information for adult, don't release. What happens? It's a security API. So although the information is available, it's not going to get now to the person who requested it, because we have monitoring, we're analyzing to make sure that's the right information before we're sending it. Now, infrastructure as a code allow the team to manage and provision infrastructure using code rather than using manual processes, right? So Terraforms, this is a tool you should know when it comes to building infrastructure and then being able to deploy what data from one area to another. It, it's a very powerful tool that is being used, right? They're used to define infrastructure configuration that are automated version control. So Terraform will simply kind of give you a command, or how will this be configured? How should we actually get into this? So it helps us to stay consistent. Let's say that today we are releasing, I'm going to use a practical example. Let's say that we want to be able to maintain our computer in a way that it stay up to date with information. Right. The first day we run or we clean our server using the app cleaning, what was it called? A certain application cleaning system, which is compatible with, let's say, or let's say we use a certain application system that can run the system in 3 minutes and the system is clean, right? And then the next time we want to do a cleaning, we'll use another one that need to go for 1 hour. The next time we want to do it, we'll use another one cleaning system that will run for 3 seconds. What's happening? We are not being consistent with the way that we are instructing our system to learn on how to operate. So in this case, the system will not gain a balance because there's lack of consistency in the way that we are sending information to the same system to perform the cleaning. So another way would just be like, every time you give a command and ask your computer to shut down, right? There are steps it goes through, step 1, step 2, step 3. Just imagine day 1, the system is allowing it go through 5 steps. Day 2, it goes through 2 steps. Day 3, it go through what happened? It's not consistent. The way the system is set is not consistent. So most of the time, the system itself might be confused because you might give a wrong command at a wrong time. So infrastructure as a code, when we write this code, it simply means that every time you press shutdown, go through 1, 2, so there's a command on how it should be shut down. When it doesn't follow that command, what happens? There's a default in the system. But if we definitely don't have a defined way by using this code, it's going to be default. We have a default. We have now the core technology tools. What? Data management, data management analytic. Right. So these are also tools that you should know, at least 2 of them. How do we manage data? Data is very important for decision making, especially if you're especially if your case study is talking about data migration and cloud data migration and cloud system. You should understand how data is being managed, right? SQL, no SQL, MySQL, right? These are like really data warehouses, MongoDB, and all the different data warehouses. You need to know them. Now, for your analytic platform, learn these 2. All right. Anyway, these 3. Google Analytics is easy. Learn Power BI and Tableau. At least take a minute and watch what is needed for Power BI. How do you put in data there? How do you analyze data there? You don't need to know how to do it, but just learn it. All right. And make sure you integrate it in your resume as well. Then we have monitoring and performance management, right? How do we monitor a system? We need to make sure that we have a good health system. How do we evaluate to see if there are bottlenecks or not, potential issues before they impact the user? How do we monitor that? So we have monitoring tools that are here. So Relix, Dynatrace, Prometheus, and Grafana. So these are tools that could help you to monitor the system, right? So, and now the advantage of us discussing this tool is, for instance, you can simply say, oh, my team was more focused on monitoring the performance of the application, right? So they check on every security. Now you will need to learn one of these tools and now look at how you can talk concretely on this. Now, it might look like it's a whole lot of information. It's not. You just, when you get to your project, you just need to pick out what tool you want to integrate in your case study and write that out and practice that. So incident management tools. What are incident management tools? ServiceNow is the most popular, right? How do we effectively manage cases that are coming out? We always have system management tool. We have a ServiceNow ticket and stuff. Unexpected event, right? So unexpected event, how do we actually manage that? So these are like things you need to have it like now. We need to work on it immediately. If not, they will disrupt the whole system. And then we have collaboration tools. The simplest. I know everyone knows this one, right? Confluence, SharePoint, um, Notions is not really that popular. Confluence, SharePoint. We also have your normal collaboration team, Teams, or again, Zoom, and all the other communication tools need to master them. Security and compliance, very, very important. Also WhatsApp, Nexus, Sneak, right? Checkmark, all of these are master one security tool. Identify and address security vulnerability in a system, right? Sneak is widely used. Nexus, Checkmarks, also a lot of companies use them. There are so many out there. Compliance tools such as GDPR, HIPAA compliance, ensure if you're in a healthcare system, learn compliance tool from the healthcare system, especially if you have a health industry on your resume, right? So very important. And lastly, Agile metrics reporting. Jira, Rally, Azure DevOps, Power BI, and all the rest that you can name them. So you notice that these are not too many tools. These are just like things that you need to be aware about and intentionally learn how to use the language in order to integrate them in the whole process. So very, very important. All right, perfect. So, great. Was my screen visible to everybody? Okay, perfect. All right. Any question? And now we're confident on what we need in order to become technical Scrum Master, right? Yes, Ma'am Tulu.
Okay, in one of my case studies, in one of my challenge studies, there was where we are building we got a disappointment for our third party vendor that were supposed to deliver APIs. In the studies, we created a mock API, but to be honest, I don't understand what mock API is. How is that created? How do they get to that level? What is creating a mock API? How does it relate to the disappointment from the vendor? I don't know
Okay.
whether I'm clear.
First thing is, what applications were you working on?
We are working on a web application. I mean, on a, yeah, it was a web. I mean, it was a web application.
What's the web?
Working on a new future.
What future it's about? What is the future all about?
The future is about it's about I forgot. I'm
Okay.
spaced out right now because I mean I've consumed so much.
All
But
right.
I think it's crowd related.
Okay. So the first thing you realize is that what you're working on is not concrete. So it's difficult for you to make a concrete case. So
Okay.
you cannot tell me you were waiting for a third party API and it wasn't delivered, and then you use a mock API. Now, what is going to make sense is that you want to first of all start by giving me your case. we're building a financial application to be able, we're building a mortgage lending application, we're building, that's what makes the case. It's not what you're saying now, everyone can say it. What helps you stand out is your environment, right? So you cannot go and tell me everything about container, and then you're unable to tell me, all right, we're trying to segment data from different vendors, or my company was providing services to 5 different companies, Uber, these, and each of these companies have their own containers. And then we're trying to connect. Now, this is what makes the case. But then, if not, I cannot be able to judge if your failure of the API and using a mock API, it doesn't really make sense, right? Now, okay. But then let me talk a bit about third-party APIs. Now, third-party API simply means that, let's say that I'm launching my own startup company, right? And I need to run my own, let's say, learning system, right? Right. So Radar runs its own learning system. Now I can borrow APIs from Udemy, or I can borrow API from Dashlearn or any company that have already established this learning system. And then, although I'm hosting that learning on Radar platform, I don't own the API. I'm borrowing it from there, which means that any day Udemy shut down, my own platform is going to shut down because I don't own the API. So we can have a contract for Udemy to supply me with the necessary connection that I need to use. Alternatively, I can work with my developer and build my own system from scratch, which is what we have. So we don't depend on any other API. So the developer now need to build anything from scratch, which means that if my system is default, I will not need to communicate with Udemy or any stuff to see if they have a problem. My developer can go into my system and they can be able to fix the problem. Right. So that would be your case. Meaning we are working, or you were relying on an external API, which you need to give a concrete one. And they could not deliver on time because their system was down, and then you were now running. So you need to temporarily work to build your own API to sustain the delivery of that application.
Oh, okay. Now I get it.
All right.
Thank you, sir. Thank you.
Thank you. Daniel.
Yes, Doc, thank you very much. It has to do with the API. I just wanted a better clarification on that. You were using the example of the ChatGPT, for instance,
Yes.
that if you give it a query and that message is sent, let's say you request for, you write it in words that you need to create a picture of a marketplace.
Yes.
And that query is sent. Yeah. Is it the API that is able to interpret that query and then be able to send that message to give you the request that you sent in the first place? I just need clarification on that.
Yes. So the API is the one that goes behind and check. Okay, take for instance, right? You come to your restaurant and you order let's say you order as it go, you order
jollof rice.
What's this famous Ghanaian dish with the rice and beans?
Wache.
You order wache. That's the name I was looking for. Now you order wache. Now, your waiter will go to the people who are cooking.
That's right.
They can come back and say, sorry, we don't have wache. So your waiter is the API. The information is somewhere. So API need to go and scan and ask the necessary cook in the kitchen. Do we have this? Do we have this? Now you might order wache and maybe with something else. it might only come back with watching like, sorry, we don't have this drink you were looking for, right? So API, it's more like a connector. It only goes and look at what is there. If it's there, it brings you. If the system cannot, it doesn't have the information to convert it to a picture, it will come back and tell you, sorry, your command could not be executed, right? Okay. So API is a messenger that goes and look for it, then bring it back.
All right. Thank you very much.
All right, open.
Good morning, everyone. Thank you so much, Doctor, for this very insightful session. So I have two questions. I was recently having a discussion with a friend on in Radar community as well, and he didn't quite agree with me that I could use SDLC for a data migration project. So we had a bit of argument on that. So I don't know if you could help to shed more light on that, how I can explain data migration projects using the SDLC. Then secondly, on the Power BI and Tableau, I know those tools are used for data analysis. You can use it for reporting, dashboards, and the likes. But I'm trying to understand how developers are able to integrate that into their projects. For instance, if they are building a software or building an application, how are they able to integrate like the likes of Power BI and Tableau into such projects? Thank you.
Okay, great. So your first question, migration project, you're just moving data from one point to another. So it's not an SDI. You cannot use SDI because you're not building anything, right? You probably using part of it. You're deploying from one, you're moving from one part to another. So you cannot use the whole concept of SDLC if all you're doing is a migration project. Now, where you might apply it is that sometimes you might need to build the infrastructure, or you might need to build the server from scratch, right? Which means data has been migrated, but there are no container to hold the data, or there are no servers to hold the data. So you might need to now build the server from scratch. Now that's where now you apply your SDLC, because you need to go through an application development system. But if your containers are already there, let's say you're migrating to Amazon Cloud or so, which we already have containers there, you probably would need to do segmentation and not build anything. So in that case, you would not need to talk about SCSCC. Wow. Then on your second question, Power BI is not, it's a ready-made application. It's an application that you integrate, right? It's just like we use Zoom and we use Teams while at work, right? They are not developer that builds the team or the Zoom that is being used. It's a plug-in that is owned by a whole company that's integrated in order to help us analyze data.
Okay, thank you so much. So how do the developers use it? I know they are doing some coding backend, and the front. So I'm just trying to understand how do they just use it for reporting?
They give commands. The developer are not using it. It's more like we integrate, right? You might have your system engineer, right? We integrate it in our whole process. Not every company might have the capability of paying for the Power BI license to analyze data and all of that. So they will rely on the data that you probably give them via your report on the Jira, or maybe you put them on Excel, analyze and give them. Right. But then there are companies with big data. Power BI simply kind of get in, do all the data for them, and then showcase the result for them. So it's more like you just need to write an API or a code, API simply means we're writing code. Write a code that says that all data that is collected from this should be submitted to Power BI. Then you go into Power BI and you also write a command. You use Python to write your command and tell Power BI how to be able, what is the format in which you want the data to be presented and all of that. So
Okay, thank you
it
so
needs to
much.
be configured with the help of a data, what do you call it? Data administrator,
Okay,
data admin or data scientist.
thank you.
Yes, Nelly.
Good morning, everyone. Good morning, Doctor. I wanted to also add on to what Doctor said about the first question, because I actually, one of our project was to move data as we were implementing Snowflake. We're moving data around. And one of the ways that I was reporting on the project, well, I was required to report on the project, was using SDLC to report. Now, where SDLC came into play is when the whole SDLC involved planning, analyzing, designing, coding, testing and deploying and maintaining. And the data that we were moving had to be restructured before moving during the whole ETL process, extraction, transformation, and loading. So the way I reported on the planning side of things, because I had to put all those stages in as we move along with the project. I could show to the stakeholders where we are in the SDLC. So during planning, we were just deciding on which part of the data, which data was going to be moved and all of that. And then we analyze that data to see which one, the different structures of the data, which one is going to have to require coding, which one would just be a carry and dump. And so that's how the analysis part of the SDLC came into play. And then we had to design how the whole movement was going to go along. The data engineers had to provide a system architecture of how the whole movement and with the different pieces, applications that will be used, because we were using Agile Databricks. We were restructuring and having everything into Snowflake, because Snowflake is was going to accomplish more than what Agile Databricks was doing already. So that was the architecture. The design part of it was presenting that architecture of what, how, and we will move the different pieces. And then we came now to the development and coding part of it, which we had some engineers that were writing codes to restructure some of those data that were actually scripting. Some of them were doing writing APIs and that will capture data from different provider, because I work with an insurance company, from different provider systems to move that data. And then there was a deployment. So then there was the testing and then the deployment. Testing to make sure that when the data got into where it's supposed to into the final destination, it's integrating correctly and is doing what it's supposed to do. And the maintenance part of it comes into play. I don't know if this helps you to see how you can put that SDLC into data migration project or data management project.
That's a great overview, Nelly. So yes, perfect. So now Nelly was acting not from the perspective of a Scrum Master, but then she was acting from a perspective of a product manager or a product owner, because you need to oversee the end-to-end process, right? We want to know at what phase. Nelly, were you acting in the capacity of a Scrum Master, or what was your capacity in that project?
Project manager.
Okay. Now, she was acting in the capacity of the project manager. You need to be able to do all of that. But then if you're talking from the perspective of a Scrum Master, you will not need to do all of those analysis, except you have the project manager / Scrum Master, then you can do that.
Yeah, yeah. Actually, they hired me as a Scrum Master, so it was project manager. They say Agile project manager. I mean, that's some of the things that, especially when companies, they don't want to spend much on a separate project manager and a separate Scrum Master. Sometimes you will see those opportunities that say Agile project manager. I still had to run Scrum ceremonies and stuff, but then in the background, I still have to do all this extra stuff and resource management and all.
Yeah, perfect. That's great. So yes, that's a deep insight, Nelly. Thank you. I appreciate. Any other
My
questions?
pleasure. Thank you.
All right. If there's no other question, any other extra question that might not be on what we shared today? If you have a burning question that cannot wait, you have 2 minutes.
Yes, sir. Please, can you send us the slides that you used for this training, sir?
Private property.
We understand it's your private property, but it will actually help us also to.
No, I cannot share them. It's still under working. I'm still building on it, so I cannot share them at this point. Right.
Okay, great. No problems. Thank
I'll
you.
see. I'll be able to create. I'll create what they call. I'll create materials that I should be able to share. Yes.
I believe the recording will be shared. So I mean, if you
Yeah,
want
the recording will be shared as well.
so you can go visit the recording and then create your own slides.
The information is also available on the web. What you learn here, you can go search and get it down and prepare it yourself.
Thank you, sir.
Okay, perfect.
Let me see.
Oh yes, Ijidema.
Thank you so much, Doc, for this insightful lesson. I want to ask a question based on my project that is also a data migration project. What best infrastructure would I say that, because on my data project, I am transitioning from on-premise to AWS as well. But I was just wondering what on-premise tool or software is best to say I'm transitioning from, and also what visualization host and database. I just want to find how I can best link it.
What have you been using so far?
So basically transitioning from on-premise, using Oracle database and VMware for visualization and running in a Windows server. That's basically what I have right now.
Okay. And what type of what's your case? What's the case?
Okay. It's a date. When you say case, do you mean what project or?
Yes, the project.
Okay, yeah. So we're transitioning that I work for a company and we're transitioning our data because the data currently, like we have large data and we're trying to transition to AWS because of cost and
Yeah, I understand, but it needs to be a data for a system or then HR when you say you
okay, yeah, so it's yeah, it's for multiple departments from sales, marketing, and the finance department, so basically transitioning their data.
Okay, into a cloud.
Mm.
All right. Let me see.
Thank you.
Coach Al and Coach Nelly, I think you can answer that. Coach Al.
You got to be careful because you just mentioned Oracle has a cloud. If you say Oracle database, I'll ask you what type of Oracle database are you working? Is it 12C was it no 11G or was it so you got to be careful because Oracle has one, right? But where the company but chose to utilize AWS rather than just saying I mean, I'm just thinking of it that way, having worked with Oracle databases, that Oracle also has a cloud platform. So it's like, okay, if Oracle has one, it's much easier to merge their on-prem database into their Oracle cloud, or it's a company's decision rather than using Oracle cloud to transition into AWS. So you probably want to make that distinction. With my only suggestion.
I'm trying to yeah, I'm just trying to understand what you mean. Like, I get that Oracle has a cloud, so you're trying to say that the transition story should be different. If that's what you're trying to say.
No, you're saying
Which company are you working with? Which company are you using?
Okay, rocket companies.
Okay, then you're good. I think Coach Al was because you mentioned something from Oracle, something to AWS. So
Yes.
thinking the company was Oracle, but if your company is not Oracle, then you can make a choice of which of them to use.
Quick
Nelly,
question.
yes.
Is your company a financial company?
Yeah, rocket companies actually also deal with they also do financial loans, but it's more they do loans. It's more like a company that they give out loans, mortgage loans, and all that.
Mortgage back
So
something.
so the reason I ask is because a lot of highly regulated companies, like industries like finance and healthcare. I'm sorry, my son. So they, because of securities and all the regulations and whatnot, they used to have a lot of their data in the mainframe, and then in all those mainframes, especially I know for sure though, the financial industries, some of them like PNC, during my research on PNC, they had a lot of data in IBM mainframe systems, which is like on-premise kind of thing, right? And then as the cloud is becoming a little more and more secure and easier to operate, a lot of these different companies, they're moving some data, like transactional, like regular administrative and transactional data, like not like people's personal accounts and stuff, but more like those emails and stuff. Those are some of the data that they're moving to the cloud because it's more manageable. So I don't know if this helps to help you. You can use mainframe. In my situation with the insurance company, the data that we're moving, we have a distributed data store, like a big data store, which is on premise, and in that on-premise, we have it's like SQL servers. A lot of our data was from SQL servers on-premise and moving them
Okay.
to cloud SQL servers. I don't know if
Thank
that
you.
makes sense.
Yeah, I'll do some research. Thank you.
Yeah. So some of those we had to buy some servers, some SQL servers on cloud to move the data to, because there we can just spin up and replicate those servers and scale easily, compared to those that we had on premise in our data store on premise.
So what Nelly is saying is the core of those especially when it's a mortgage back, the core of those information are gonna stay in. It's just the administrative task basically, right? I think part of that is the Dodd-Frank. I forgot some of the federal regulations from the financial side. I know Dodd-Frank is one of them that basically put strict conditions, the CFR and stuff, into managing the personal information when it comes to financial, because you don't want your personal information to the extent that deals with your social security or your whatever the mortgage thing to be in the cloud, right?
Yeah,
Right.
they're still very skeptical about those.
Mm.
Yeah, some information, they're still very skeptical about moving those to the cloud. But a lot of those just random, those email communication, customer service calls and blah, 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 that are recorded, they're moving those to the cloud. And then it could just be, like I said, it could just be SQL servers, data in SQL, like just buying more servers in the cloud, because the ones that you have on premise is not easy to scale. And you can talk about IBM mainframe, which house a lot of those on-premise data from my research for some of these financial industries companies.
Yeah, Doc,
Thank you.
I think we also got to be mindful to just throw it out there. We're moving from this to cloud. You got to understand do a little bit research, like what Neil was saying. The company that you have, what they do, because not everything is just because with this cloud, not everything just go to cloud. Even AWS, it's more of this transactional it's just to speed up the administrative process of information that goes back and forth. We just be mindful, not everything because we say AWS brings or cloud has brought efficiency. Basically, that's how I look at it. But now we shouldn't be jumping to everything cloud. Make sure we do our due diligence into what the company you have, what are they working on, understand their industry. Some of those information may be available, some may not be available to the public.
Thank you.
All right. Thank you. Coach Enke, your hand was up. I was ignoring.
Sorry, Coach Nelly touched on what I wanted to say because we are technically doing some of those right now. So I'm in financial as well as part of our data governance project right now. So we're in the analysis phase of trying to figure out exactly where we want to store those data. But again, to Coach Nelly's point, not everything is gonna go. We are focusing on the emails, the different kinds of data to make sure they are secure. So, but some of them, they are still skeptical about being on cloud for security breaches. So I just didn't want to repeat what Coach Nelly said.
All right. Thank you very much. Now, before I go to Daniel's question, so we are going to be setting up interviews for all level 2 students, all active level 2 students. And our admin is going to be getting out to get a schedule. So it's going to be compulsory. It's compulsory. If you're not interviewing, you're inactive. If you're in level 2 and you're not interviewing, so it's going to be compulsory. So we don't want to reach out to people. I'm not ready. That's not acceptable. So we are going to be scheduling out interview sessions so that we can get to understand how prepared you are. Now, this means that everyone needs to master both their resume and their case study and being able to talk about it. So we'll get a database this week, this coming week, expect all of those details and get prepared for interview. And those who are definitely not meeting up with the compliance of the system, you're also going to be receiving messages from our admin. Now, this also is going to not just apply to students, but also to our coaches. We don't want people who come today and after 5 months, we don't see them. So please, let's make sure that we're staying consistent with what we are doing. And let's make sure that we create value to the community. Because when people just come in and out, you don't respect regulation. It's like you can come in and come out at any time. So we're going to be doing quite some restructuring very soon. Not taking anyone out, but just making sure that if you're here, especially for level 2, at least a week, you should be evaluating yourself and knowing where you are and knowing why you're not moving ahead so that we can better support you. Yes, Mr. Lord Dan, please go ahead.
All right. Thank you very much, Doc. I'm curious to find out. I think in your deliberation, the issue of how do you call it, Power BI and Tableau came up, and I just wanted to know, just as in the case of some of these delivering apps, like Spark, VHO, that kind of stuff, right? Their platform on their platform, they've been able to integrate some of these, like let's say Google Map and Waze into the system, so much so that when you are making a delivery from one point, from the warehouse to the location that you're delivering the item, you don't necessarily have to come out of the system to input the address to be able to do that. Yeah. And it's like they've automated that process into their own system.
Yeah.
So in the same fashion and format, is it also possible that an organization can integrate Power BI and Tableau into their system to be able to analyze data as part of their automation process?
Yes, very possible. You can actually ask Tableau Power BI to deliver a report at the end of every day, at the end of 1 week, at the end of 2 cycles. And if those who have access to the product could basically pull out this report at any time.
Okay. All right. Thank you very much.
Yep. Yeah. But then that also go with a question mark, right? For instance, we're working on a case and there are certain report that could not be automated. Certain financial report could not be automated because even after you submitted, let's say, your timesheet or you submitted a project cost, there's an evaluation that goes up after that, and they can readjust the cost and all of that. So in that case, we could not kind of really rely on automation report as a valid way or as an authentic way of validating the cost spent. So in most of the cases now, all of those are going to be, you request them manually, which means that when a period is clear and it goes through auditing and is validated in the system, then the person in charge now can give a command to pull out that report from this period to this period, which has been cleared. Right. So the same way when they were talking about when you work with the finance, not everything is automated or not everything is automatable, right? If that word exists. But then there are also regulations. You can do that, but you also need to take into consideration the kind of data you're working on and also how to deal with the data.
All right, thank you.
All right, perfect. And James kind of made you know, talking about your project migrating data to cloud. He made an important point that most often cost is not one of the major reasons, because it's cheaper to keep your own data in your own servers. So cost is not a reason for migrating. We don't migrate to save cost, but most often migration is kind of for better data governance, to be able to give easy access, to be able to share those information, and also for better customer experience, right? For instance, if we have a bank in several locations, if some of the data cannot be accessed by cloud, it means that I will need to call the other location to be able to. But most of their servers can also have like networking that can do that. But for simplicity, most often they switch some data to cloud for better data governance. All right, perfect. So this take us to the end of our session today. So assignment for all our team members interviewing, we're working to get slot where you would evaluate yourself. And for those who are also active, not active in a way like you're really serious about getting the jobs and other stuff, we'll find a way also to incorporate a system of mentorship where we can constantly get that accountability, review what you're working on, and give you updates weekly. But doing all of this also means that it comes with a cost on your own part. The ability to stay consistent, the ability to participate fully, the ability not to give excuses at the point where you are not supposed to give, and all of that. So, and what we're also working on that might definitely come up in a month's time, I'm hoping that we're also working on a playbook, which means that everyone will know what they need to do and will know what will happen if they don't do what they need to do. So you don't have to be calling people and like, add me here, don't add me here, and other stuff. We're trying to be agile, right? And let's be agile. And please, you know that you can set your calendar to remind you when your meeting times are, and to remind you where to find your meeting links. Everyone needs to know how to do that, right? Because most often, like, oh, I'm looking for the meeting link. No, these are not things you should look for. You need to have them like handy, even when you work as a Scrum Master. Most often, you need to have your go-to page where you can easily find what you use almost on a daily basis. So every time trying to find where if there's a change that happened, you'll be able to notice that there's a change that happened because what you previously have is not working. So you can now make the right inquiry to get the result. So let's be serious, let's be committed, and definitely we are going to go through successfully. Everybody have a good Saturday, have a good weekend, and see you on the other side.
Thanks, Doc.
Thank you.
Bye, Coach.
Thank you.